Hey, what is good you guys? I am Jaideep and welcome back to yet another video of our channel. And in today's video, we're going to be talking about data classes in Python. Topics which we're going to cover is what is a data class, why use a data class, how it is different from a normal class, certain methods such as Asdict and Astuple which are available to convert the data class into a dictionary and a tuple as the name suggests. We're going to look at how mutability and ordering can be preserved or obtained rather. Then we are going to look at fields, a special construct which allows us more control over the variables which are part of the data class. We're going to look at the post-init method as well, and then we're going to finish the discussion with performance optimization using slots. Before we get started, I'm using the Python version 3.10.4 for this particular tutorial, and hence all the functionality would be perfectly compatible with this version. Now, to create the virtual environment and manages this package, I'm using something called as Conda. If you're not aware of what Conda is, I do have a tutorial for that on my channel as well. And before you get started, I do suggest you go and watch that. So I'll leave a link to the Conda tutorial in the I button. Coming back to data classes. The data classes were first introduced in Python version 3.7. Backward compatibility is also available, but that is out of the scope of this tutorial. If you do feel a need for that, you can request a tutorial of that in the comment section as well, and I'll try to make one. What we have on the left hand side is a normal class. Now, for a normal class, certain methods are necessary to make it meaningful, such as the dunder init, the dunder wrapper, the dunder hash, the dunder equal, amongst the others. There are other methods as well, which are available as part of the object class. So let's just open this as well. You see the definition of the base object class. There are a many methods which are available, such as the greater than equal to, the less than less than equal, and so on. So all these methods are necessary to provide certain functionality of this class, but writing all these methods manually has its own problems. Firstly, we don't know the best practices about that, and secondly, it's just a lot of code. So you can imagine the amount of pain which you'll have to go through if you have to implement all these methods manually, and especially if your class is just a is a data holder and doesn't have any complex logic. So that is where data classes come in. They help us do two things. They help us generate all the boilerplate code, and methods which are implemented in the Pythonic way, because obviously they are done by the experts. So that is about data classes. They are nothing but code generators, and they help us generate a lot of the boilerplate code which is available as part of the normal class. The what part is clear. Let us look at the why part. Why would you use a data class as opposed to a normal class? Now, if you look at this class on the right hand side, the inventory item, it is clear that it doesn't have much logic, much more processing to do. It has just 3 variables and then a total cost method. So it's fair to assume that this class was written just to hold certain data with respect to inventory item. Nothing more, nothing less. It doesn't have any complicated calculation logic as well. So classes such as these, which are intended to just be data holders or placeholders for data of certain type or in a certain structure, are perfect examples of data classes. Here, what we can do is we can group all the data together under the class name, and we don't have to write all the initialization and all the methods such as wrapper and everything ourselves. So these are perfect candidates where you use data classes. That is storing of that is classes which are just data stores or containers, and as an added advantage you get all the methods pre-written for you by Python. Right, enough theory. Let's jump to the Python console and do some practical. So what I'm going to do is, from the normal class I'm going to import all the items. So from normal class, import star, and just notice that I've commented the wrapper method. Now this will show us why data classes are important and how much trouble they save us. Now let us create an instance of the inventory item class. I is equal to inventory item. I is equal to inventory item with the item name as 1, the period price as 1, and the quantity as quantity at hand as 1 as well. Now the init method is available, so initialization took place. Okay. Now if I just do I.name, the item name is available, but let us do a wrapper of I. Now if you see the wrapper, since the wrapper method is not implemented by hand, we do not get a correct string representation of the object. We just get a random memory address of the object, and so on and so forth. So the clear disadvantage of this method is that we have to write all the wrapper method by our own hand. Now, as opposed to that, let us see the example of the data class, and let us see the similar implementation using a data class. What I'm going to do is, from example data class, import star, and I'm going to do similar. I is equal to inventory item. Let's do an I2, and so this is the I example which was available as part of the which is a normal class, and let us do an I2, which is the data class. So if you clearly see, the data class is much better. The wrapper method is already available. You did not have to implement anything. And similarly, I2.name is still available. I2.unit price is still available. So if you see, we got the functionality of the wrapper method without having to write it. So this is all the lines of the code which it saved for us, and this is just the starting point. The init method was also already available. We did not have to write the init method for ourselves. So this is how practical. So this is a practical example of advantage of data class over normal class. Let us quickly jump over to the documentation of the data class. From initialize the data class, we didn't give any initialization parameters. We just created the data class using the data class decorator. But that is just the tip of the iceberg. More to offer, and you just need to ask for it. A lot of arguments which you can supply and control the behavior of how this data class behaves and what methods are available. So for example, the init method by default is true, the wrapper method by default is true, and the equality by default is true. So these three methods by default will be available for each and every creation of a data class. So whenever you decorate a class with add data class, these three methods by default will be generated. For something, a package inspector or maybe some third-party library which would help us visualize the class which is created when we decorate a class with data class. But unfortunately there is no such solution available. Maybe worth developing if one of you has time. There's something called as Dataclass Inspector, but the last version for that was released in 2018, and I just tried it before this tutorial. It doesn't work anymore, unfortunately. So there's actually no way to see the code which is generated when we decorate some class with add data class. But yeah, I think so, that is it is what it is. But yeah, coming back. So when you decorate a data class, when you create a data class, there are certain parameters, certain arguments which are available. If you're a person who is fussy about arguments and parameters, using parameters interchangeably, I'm sorry about that. Class, just like we did here, we used all the defaults. Yeah, we did not specify anything, but that is just the tip of the iceberg. What you can do is you have additional customization available. So by default, as I mentioned, init, wrapper, and equality are true. So these are definitely the three methods which you will get as part of the data class creation. The others, such as order, unsafe hash, frozen, match arguments, keyword only, and slots, are by default false. So they are by default they're false. You can just make them true or provide alternate values based on the documentation and alter the behavior or functioning of how the data class is initiated. So we'll see some of them. So for example, if we do an order is equal to the order by default is false. If you do it as a true, then what happens is you can order the class instances which are created. Similarly, unsafe hash is equal to false. I think this name again is a little bit tricky. Unsafe hash is equal to true. So by default by default we know that classes are mutable when you create an object of class. So if you create an object of the inventory item class, we know that at any point we might feel the need to change the name or the unit price. So for example, if the iPhone is on sale today and iPhone costs $100, and tomorrow it's on sale and it costs $50, so we know that the unit price will go down. So classes by default are not are mutable. They are subject to change. So that is why this unsafe hash by default is false, because hashing of mutable objects is not something which we want to do. But if you're someone who wants to change that behavior, you can say set unsafe hash is equal to true, and basically it will give the ability to hash the class, or at least try to hash the class. If the object has some mutable object such as if the object has some mutable variables such as list and all, then be a problem for you. Frozen is equal to false. So by default, as I mentioned, classes are not something which are immutable. The attributes or values within a class are subject to change. So by default, frozen is false. But if you set it as true, then the class will be frozen. That is, once the instance is created, then you'll not be allowed to change it. Match args keywords only. I think as the name suggests, that if you saw the creation just a minute back, I think here, not here, but yeah, here we created the object using we just passed the arguments to this and the object was created. But if you want to make these arguments as keywords only, then you can set the keyword only is equal to true, and slot is equal to false. So slots is something which can be used for performance improvements. This is a general Python course. At the end of this tutorial, we'll see what happens when we set slots is equal to true. It was a quick debrief about what additional arguments you can supply while creating a data class and get more behavior. Also worth pointing out that when you set some of these flags when you change the values of some of these flags, Python will generate additional code as well. So If you do order is equal to true, it will generate, if you somewhere here, yeah, if you do order is equal to true, so in addition to the wrapper init and equal to method, less than the lt less than equal greater than equal methods will also be generated. If you see, just setting one parameter gives you so much of the code. That is a clear advantage of data classes. Again, enough of theory, let us look at some practical examples of how these arguments can be used. Now, to demo that, what I have is a small class which says a profile without order and freeze and just a profile. So let's assume this is a social media profile where you have a username, number of followers, and the number of people you follow. So these are the three variables which are available as part of this class. Now I have two classes, profile without order and freeze, and the second one is a data class, but here order is set to true and frozen is set to true. So we just saw that when we do order is equal to true, then the ordering of these classes or the instance of these classes is available. And when we do frozen is equal to true, then basically this class becomes immutable, and then we cannot change it. We cannot change it, or we cannot change the value once the instances are created. Firstly, we're going to see how the class behaves without the order and the frozen, and for that I'm going to import this. So let's go back to the console and let me restart this. And from example frozen order import star. So let me create three instances. So pf1, then pf2 and pf3. Pf3 I think is similar, so let's try to change something. So c, and let's give this person 4 followers and maybe 10 following. So let's now expect pf1, pf2 and pf3. So these are three nice profiles which we have created. Extend this, yeah, pf1, pf2 and pf3. So these are three profiles. Now if I do a pf1 dot username, we get a as the username. Now pf2 username is equal to, say, changing this now, so pf1 dot username. So if you see, this class is mutable, that is we are able to change the attribute. So because we've not set the frozen is equal to true. Now also by virtue, because this class is mutable, if we know that this classes and all cannot be used as instances or cannot be used as keys for a dictionary, neither can these be ordered. So for example, if I just do list of underscore profiles is equal to, say, pf1, pf2, comma pf3, or I think what we'll do is pf3, pf2 and pf1, and let's do a list of profiles. Let's display the list of profiles. So if you see profile without freeze order, username C, username B and username A. Now if I just try to sort it off list of underscore profiles, so if you see that sorting is actually not supported. So that is the default behavior without supplying additional arguments such as order and frozen. Firstly, we are able to change the attributes of the class, and because this class is because the attributes are changed, then we cannot use the classes as keys to a dictionary. Because the order by default is false, the methods such as the methods for comparison are not available, and hence the sorting also did not work. Now let us create a second class, or let us create instances of the second class. So what I'm going to do is, again, to this, I think we don't need to import it again, we've already imported it, but just for safety's sake, now let us create the same three profiles, and profile 2, the profile 3. So if you see, we have created three profiles, 1, 2 and 3, A, C and C. The usernames these names cannot be same, but just for this demo purpose I want and for the specifically for this ordering purpose, I've kept the name as C, and they are only differentiated by the number of followers. So now what I can actually do is, because these are mutable, what I can just do is I can do this as well. Dictionary of profile, I can use these profiles as actually keys to a dictionary, because we know they are frozen, that is they're unique and they cannot be changed. So just to ensure the uniqueness, if I try to change one of the variables, or if I just try to change the username, there will be an error which says that cannot assign to field username because of the frozen instance error. If you're curious as to how this implementation works, the set atom method for these is not available once you mark a class as frozen, and hence you can only read these properties, and you're not able to set them again. Also, coming back now, if I just do list of profiles is equal to profile 3, and if I just try to display this, so if you see, currently this is unsorted, and if I just try to sort it off list of underscore profiles, So if you see, we are able to sort this as well. Now earlier in this example, the sorting gave us error that because there was no comparison implemented, it couldn't sort. What it will sort based on, right? And because there is no comparison available, there are no comparison methods were implemented. But if we set order is equal to true, the comparison methods such as the ones discussed here, less than, greater than, and all those are available, and hence, Python is able to compare them, and hence sorting is also available. So this is a bit about the customizations which are available, nice and handy. And again, all this code is available as part. So all this boilerplate code becomes readily available. You did not have to write a single line of code. You just have to pass on these customization parameters. Very very handy if you ask me. Moving on, now let us talk about the support for conversion of a class object to dictionaries and tuples. So that is also readily available as part of the data classes. So from the Dataclasses module, you can simply import the Asdict and the Astuple method, and then it can convert the object of the class into a dictionary or a tuple. So what I'm going to do is I wish I could type all of this, but I think it's just better to have everything ready and concentrate on adding value rather than typing all this. So what I'm going to do is from example Asdict and Astuple, import star, and we're going to create an object of the inventory item class. And so let's see the object. So we have an inventory item with item name 1, unit price 10, and quantity on 10. So if you want to convert all of this, so now if you just do a type of I, so it is it's an example of the inventory type. It's an object of the inventory type class, and nothing surprising there. It's if you want to convert this inventory item into tuple, so that is also very easy. So what you can do is from data classes import Asdict, Asdict and Astuple. And now if I do Asdict of I, which is the object, you will get a dictionary representation of this object. Let's look at I again. So this dictionary representation of this object is readily available. So, and similarly Astuple, if you see, a tuple representation of the object item I is available. So these are two handy methods which are available as part of the data class implementation. Moving on, the next powerful constructor which is available as part of the data class is something called as the field method. Now on the right hand side, we see the previous example where the only degree of control which we had over all these variables which we use as part of the class creation is the default values. What we did is we initialize that the number of followers and the number following should be 0 by default, because when you create an account you actually don't have any followers. So that's the whole logic of this. But this is just not it. This is not the only degree of control. If you want to have more control over this, then what you can do is you can use the field method. Every attribute which is available as part of this, you can specify the field, and the field, again, just like the data class initialization, comes with a lot of factory function, a lot of arguments which you can use to control the behavior. Let us look at the documentation once again. So the arguments which are available to the field method are default factory, init, wrapper, hash, compare, metadata, and keyword only. So what the default suggests, as the name what default means, as the name suggests, that the default value which is available can be supplied here. The default factory, so for example, if one of the attributes of your class is say a mutable object such as a list or a set, then the default factory which you want to be generated, you can supply it here. So when you supply default factory as a list, then each and every instance which is created will have its own access to its own default factory. If you set init is equal to true, then that particular field or that particular attribute will be available as part of the init method. Similarly, if you set the wrapper is equal to true, then that particular method will be available as part of the wrapper. Hash is equal to none, compare is equal to true, hash is equal to none, so by default it's none, so that particular class attribute will not be available to the hash method. Compare is equal to true. Again, all these methods are basically same till compare are same, that if you want to exclude them from one of the methods which we saw which are generated, then you can control that using these parameters. Metadata is nothing but if you just want to supply some additional information, this is not used anywhere. If you just want to supply some additional information about that field, you can supply it in a metadata, and this is a dictionary, so you have to supply it as a dictionary. And keyword only, so if you want to supply that method as supply that particular attribute as a keyword only argument, then you can do that. So let us look at a few examples, because that's just enough theory. So if I see if I set this number of followers, so let's just set this field is equal to keyword only is equal to true. And just worth pointing that the default and the you can only supply a default or default factory, one of the two. You cannot supply both of them together. That's just not allowed. That's just worth that is something to keep in mind. What I'll do is I'm firstly going to close this because it's no use to us, and let's jump to the console. We restart it, and so let's try this from Dataclasses import field, and from example field import star, and let's try to create this profile. So remember, we have said the username is equal to keyword only, number of followers as default 0, following default 0, and profile view by is default factory. That is, for each and every instance of this pf1, pf2, pf3, a new list will be created. So let's try to create pf1, and let's see what happens. So if you see missing one keyword only argument, username. So if you see, this is already working. If I just do username is equal to a, bad Python programming practice. What I've done, a keyword only argument should always come at last. So what I'm going to do is I'm going to just try to shift it at the last and see what happens. And so I'm just going to copy paste here just for the example. I'm going to revert it later, and let us just do this, and comma username is equal to a. And now if you see, this is work. So what we did before, username, you cannot supply keyword only argument. You cannot supply keyword only arguments before positional arguments. So now just for this demo, what I did is I shifted the username at last, and if I just do pf dot username, you will correct pf dot number, not number of followers, but is it? And if you see, it has number of followers 72, the following is 73. So pf1 dot follow. So this works as expected. Now I'm going to revert this. And what I'm also going to do is not here, but remove this field for this. I don't think we need it, and I'm going to restart this session. Now if you see, the number of followers compare is equal to 2, so we've decided to include this in the comparison. Following is equal to true, so we also want to include this in the comparison. So when the objects pf1 and pf2 will be will be checked, then these two will be available. So let's just set them to false now, and let me reinitialize this. So from Dataclasses import field, and from example field import start, and now let's compare. Let's create two objects, pf1 and pf2, and what I'm going to do is I'm going to compare both. If the both username is same, not ideal, but let's just do it now. pf1 and pf2. If pf1 is equal to pf2, this is true because we have only included the username in the comparison. Rest of the everything we have excluded from the comparison. Now let's just revert it to I didn't know it was possible to misspell true, but it is what it is. And now we have included the number of followers and number of following, in the comparison. So next, when we create these objects pf1 and pf2, then in the comparison these would be included as well. So if I just do from Dataclasses import field, from example underscore field import star pf1, and here what I'm going to do is pf2. So now I'm going to keep the username same just as before, but only change the parameters such as following and followers. So pf1 equal to pf2. So now it will return false because the number of the other parameters have changed. So let's just make pf1 equal to pf2. So 1010. So now if we just do same comparison, pf1 is equal to pf2, this will return true because all the three parameters which we took for the comparison are now equal. So this is how we can get additional control over these parameters and the behavior of the class in general by setting all these field attributes. Similarly, I think we have this metadata option as well. Now what I'm going to do is, so pf1 and let's create some proper profiles now, pf2 and pf3. Now if I just do pf1 dot So we have this functionality of someone who if you're on LinkedIn, that who viewed your profile and all that. You can see at least a couple of them. After that, you have to start paying them. I don't know. I don't know if anyone uses that, but yeah. So if I just do a view profile, and we're going to assume that pf1 is the username A, that the person B viewed the profile. And if I just do this and pf1 dot profile viewed by, if you see that the person B viewed this profile at this time. If I just do pf2 dot profile viewed by, say this person C views the profile of person B, and if I just do pf2 dot view profile, not view profile but profile viewed by, if you see the profile of this person B was viewed by this person C. So what we did was we did the default factor is equal to list. So each and every time, each and every instance will have access to its own set of data, and that is why we can see that the profiles, this list is not shared, and each everyone has its own this viewed by nicely available to it. So that is the advantage of setting default factor. That is, each and every class instance, each and every instance of this, each and every object of this class will have its own set of own set of mutable objects, and then the data will be stored there only. You can also, if you want to, view the details of these fields or what are the current parameters which are set, what you can also do is we can inspect just like ID and type and so on. This field is available as part of the introspection as well. If I do fields of pf1, if I just move this here, the description of this entire field is available. The name is username, type is string, the default is missing type, and the default factory, and so basically all the default settings which are available. Now if I just do a field, now if I, and this will give a list of all this fields, this class will have, or this representation rather will have the details of all of this. If you just want to see any one of these parameters, what you can do is supply that. So, and it is 0 index, so at index 0 would be username. So if I just do a 0, then I'll get the details of the username only. So if you see, it has the details of the username only. Now if I want to see this profile viewed by, what I can do is 0 1 2 3. So if I just do profile viewed of 3, then it will give me details of the configurations which are available to this field attribute on this profile viewed by. If you see this, the metadata I think would be available here as well. And if you see, the metadata is a mapping proxy, which basically is nothing but a read-only dictionary. So this is about how we can configure each and every attribute which is available to class using the field attribute. Okay, moving ahead with the discussion, we'll look at something called as post-init method. Now this is a special method. Now from our previous discussions, we have understood that the init method is supplied by default. And also we have established a ground rule that data classes are best used for scenarios where you want to store data, and you want to use these classes as just containers, nothing more, no fancy logic. But sometimes the need might arise that you want to perform certain operations once an object is initialized. And this is the example we have taken, that we have an employee class where we take in the first name, the last name, and the email is initialized as a combination of the first name dot lower dot self-name dot lower at somecompany.com. So once we create an object of the first name and the last name, so once we try to create an object of the employee class by supplying the first name and the last name, we want the email to be auto-populated. And this is something which you can do with the post init. So this is the method which will be called by the init itself to perform some post initialization checks. Now this can also hold a lot of logic which is a subject, or which is which is tied to these attributes. So for example, if you have the designation of the employee as well, and you want to derive the designation based on, say, certain input parameters which come in, that can also go in the post method. So the purpose of this particular example is to show the post-init method, and just to see how this works. What we can do is, from example, not this but post-init import star, what I'm going to do is is equal to employee, say Sharif and Karare, and e dot first name is equal to Jaideep, e dot last name, because that is something which we have given. And if I just do e dot email now, this email would be readily available for me. So this is how the post init method works. So any post initialization checks that can go in this method. Okay, so the last action item in today's agenda is talking about some performance optimizations which you can use as part of the data classes to get some better performance. Now this is a generic concept for Python, which is the use of slots. It's not something which is specific to data classes, but slots are available everywhere in normal classes as well. And what slots do is, instead of storing the data in a data dictionary, what they do is they store data as a list. So what happens is it takes less memory, and it also speeds up the access time. The access time, I'm not sure. I tried the time a couple of times. I didn't get much performance difference. We'll see it in the runtime live in this code, this demo as well. But yeah, definitely, if you try to compare the size, you will see a noticeable difference. To demo that, what I have is a normal inventory class where the slots is by default false, and then I have an inventory item with slots where the slots is 2. So what happens under the hood is essentially what when we set slots is equal to 2 is what will happen is there will be a slots attribute, and it will store nothing but uh, quantity. So all these 3 variables will now be stored here. So basically what we this is what slots does. It creates in-memory address or something. So under the hood, this is what it does. It creates some in-memory list for this, and it holds it. So some memory is reserved, and that is why we get some degree of performance optimization and some degree of memory optimization as well. So that is what a slots does under the hood. If you're just interested, I'm not 100% expert in this underlying things, but I just read about it, and I think this is what it does. Back to the topic, the inventory item and inventory item with slots. So what we'll do is we'll just see the demo of this demo of how much the size of this inventory item is, and how much the inventory item with slot is, how much is actually the size saving. What I've done is, so from example, import star, and to see the size of this object, what I've done is I've used a separate third-party module. You can install it from the pip standard package, and from that we need the as size of. So let us now create two objects of two classes, inventory item and inventory item without slot. So firstly, I is equal to inventory item, and the item names are exactly same. I'm not making any difference, so that it is better for comparison. And secondly, I2, which is the same inventory item with slots. So let's do an I1 and I2. So essentially they are same objects, but for one of the classes inventory item, the slots is false, and secondly for inventory item with slot, the slots is true. Now let us see the size of both the objects. So the default object without slot takes 432. I think the memory is in bytes, and the second is the one with slots. And if you see the memory which is utilized by the one with slots is, so we get a significant memory reduction and optimization of space. So this is how setting slots is equal to 2 will give you an additional advantage. In terms of performance saving, I didn't see much. So what I'm going to do is I'm going to import the timeit module, and we're going to create the same inventory item and inventory item with slot, and see how much time it takes, how much time the access of the name takes from the class. So how much time does it take to access the item 1? So for the first class without the slots, it took 0.121 seconds, and secondly, okay, so I think it's significantly faster. So let's try it one more time. So it is 0.13 seconds, and yeah, it's significantly faster. So when I tried this for the demo, it didn't give me much difference. But since then, I've restarted my PyCharm. Maybe that's the reason, or there's some cache and stuff like that which goes under the hood. But let's try it one more time just to be sure, and enter. So 0.1 seconds, and I2. So if you see, if you see now, this access became a little bit slower. So this is the performance is a little bit variable for this. I'm not 100% convinced or sold on this performance related optimization, but definitely the size, as we saw, there's definitely some size saving for that. The space saving is definitely visible. The performance or the access time, I'm not really sure. It depends, I think, on machine to machine as well. Yeah, it is what it is. Yeah, coming back to the concept, so if you set slots as equal to 2, you'll definitely get some space optimization, access optimization. It depends again. So that is it for this video, guys. This was all about data classes in Python. So just to summarize, or a key takeaway, data classes help you to generate certain boilerplate code, and they do it in a Pythonic way. Doc strings, wrappers, init, and equal to method are generated by default. And in addition, for the parameters, which is the arguments which you supply as part of the data class creation, you can get some additional methods implemented as well. Data classes are best used for classes which have which are used as containers, or which you intend which do not have any complex processing logic, but you just intend to use them as data stores or data structures. So those are the best classes which qualify for data classes. If your class is bloated or has additional logic and additional inheritance, you're better off writing a normal class, and that will give you more control over all these method implementation as well. Those are a couple of key takeaways, and that is all about data classes. Before you leave, a humble request: if you are new to the channel, if you haven't subscribed already, I sincerely urge you to do so. It'll help me keep motivated. The algorithm, do leave a like and do leave your feedback in the comment section as well. The engagement also counts. It'll help YouTube algorithm understand that you find this content useful. Thank you for watching.